Mark Zuckerberg and Meta have just announced another AI mega project. No surprises, it's a data center, but this time it's projected to take as much space as the entire island of Manhattan. It's going to be absolutely huge. Every time I see reports about data centers, I don't know about you, but to me, A, they sound kind of boring. B, I don't understand what those numbers mean. And there are a lot of numbers in these reports. But talking to experts and looking more into it, I've come to realize it's one of the biggest problems that we're facing. And it might all be because of this graph. This is kind of the key to understanding why these AI data centers might be one of our hugest requirements, but also the hugest problem that we are creating. In this video, I want to show you how data centers are cool, but I also want to show you a few of the people and companies that are trying to find alternatives to using so many resources to give us the best out of artificial intelligence. So let's get into it. Okay, I want to explain to you the most fascinating and seemingly boring at first thing. The thing that really made it click for me is understanding the difference between these two things. One is watts or kilowatts, megawatts, gigawatts, and the other one is watt hours, gigawatt hours, kilowatt hours, etc. You might think, oh my god, this couldn't be more boring, but stay with me. One is a measure of power. Think of this as a car. Power would be its highest speed and how much oomph it can give off because of it. The other one is a measure of energy consumption specifically, which is, if we go back to the car analogy, how much fuel it has in the tank. The two are kind of unrelated because there's cars that use as much fuel but can go at much lower speeds. So when you see OpenAI or Meta saying that they want to build a 5 gigawatt data center, it refers to how fast this body of computers can go, and that these data centers will have a maximum demand capacity that is unlike anything we have built before. But a 5 gigawatt data center is going to consume a lot more electricity. The fuel needed to run for a year would probably be closer to 45 terawatt hours. So the two sound very similar, but they're totally different. But what is exactly a data center? Because every time I think of one, I think of these Hollywood scenes of somebody trying to break in the darkness of the night into this facility that looks very industrial, that has inside this stacks and stacks and stacks of chips with little blue or green lights flickering in the distance. And surprisingly, that is actually what data centers look like. Hollywood did something right for once. But we're not going to go deep into what the chips are or how you can make this better, because that is for another video. A data center, its most simple form, is three things. One is computational power through the chips. Two is cooling power, because all this computation is creating a ton of heat. And three is, of course, energy, because computation and cooling take energy. But the problems don't begin there for AI data centers. They start way before. And that is the reason why I showed you this graph in the beginning, to tell you that this is the key to understanding why these AI mega projects might be so difficult to build from scratch. You see, cement production, the material that we make the majority of our buildings and infrastructure with, accounts for 8% of all greenhouse gas emissions. So the problems begin with not how we're going to power those data centers, but how we're going to build them. There's currently over 10,000 data center facilities in the world. Worldwide, there's 26 million square meters of new data centers being planned right now. Altogether, it is projected that this will add another 2.5 billion tons of CO2 in order to construct the very buildings that we're going to need for this AI boom. However, the irony is that AI is solving some of the problems that it's creating. There's currently over 1,000 companies that are working on green types of concrete. Many of them are using artificial intelligence in order to develop these new recipes for cement that are greener and better. Decarbonizing the cement production process is going to be huge, but it's still not solving the energy demand problem. And for that, you need to look a little bit further out.
So we are building very large data centers in space in order to be able to take advantage of the abundant energy in space, and also so that we can scale to very large sizes without having the permitting constraints that you have terrestrially.
This is Philip Johnson. He's the CEO of StarCloud, a company that is aiming to build data centers in space instead. They're not the only ones that are working on this problem, because sadly, computational power comes with exponential increases in energy demands with AI. StarCloud is not the only company working on space-based data centers, and they will have one great advantage, that if they put their solar panels in just the right angle, in the right orbit, they will be able to tap into the endless power of this giant nuclear battery called our sun. However, their problems will also be unique. One of the greatest challenges, and the reason why Philip said this during our interview.
Yes, we're developing the biggest technical challenge by a mile is the radiator. The radiator is what we're developing mainly in-house.
Okay.
Lots of other stuff can be bought off the shelf. So you mentioned these particle accelerators, that's the thrusters.
Is that cooling doesn't just happen passively in space. They will need to build specialized radiators that will be able to take the heat generated inside these computing modules and dissipate it into the abyss of space. Other solutions are a little bit more down to earth, literally. For example, nuclear-powered data centers are also being developed and trialed by several companies. Other solutions are focusing on the cooling part, which is very important to mention. Cooling comes in the forms of fans, which consume electricity, but also water. And that is why earlier this year, an infamous study showed that asking ChatGPT to write one email is the equivalent of one big glass of water in terms of cooling demands. Google has trialed an approach to counteract that by placing data centers underwater, as they can be cooled passively by the cooler water of the ocean that surrounds them. However, they found that the cost of maintenance and some deployment problems have made the solution so far unviable. I don't know what the future of the AI boom is. It's a technology that has the incredible potential to solve big problems, but in order to build it, it's creating some pretty big problems too. I just hope that next time you see AI data centers, whether they're the size of Manhattan or not, you understand what they mean a little bit better. And thank you so much for watching.